There's a lot in common between water flowing in hydraulic circuits and electrons flowing in electric circuits. Here's a YouTube. It's easy to understand that a flow of water will be from the region of higher pressure to the region of lower pressure. But the flow will be brief because the pressures will soon equalize. There will no longer be a difference in pressure. With a pump, however, a difference in pressure can be sustained and a flow of water can be sustained. Likewise with an electric circuit where a battery pumps the flow of electrons. Consider this simple hydraulic circuit: a water pipe powered by a pump with a valve and a section of the circuit that offers resistance to flow. As long as the pump provides pressure, water flows through the pipe. That's if we open the valve. Only water flows, not the pressure. Since water is incompressible, it doesn't scrunch up anywhere, but flows continuously. Its rate of flow along any path in the circuit remains the same. Now compare this to an electric circuit, powered here by a battery, a sort of electron pump, more precisely, a voltage source. Here's a switch and resistor. The zigzag symbol is for the resistance of the device that dissipates electric energy, say a light bulb. When we close the switch, the circuit is complete and electrons have a path for flow. Just as water undergoes a pressure change in parts of a hydraulic circuit that offers resistance to flow, electrons undergo a voltage change in an electric resistor, a bulb filament, for example. This means that electrons flowing through the resistor lose energy that is transformed into heat and light. So there are similarities between a hydraulic and electric circuit. But there's a big difference also. Whereas you have to supply the water in a hydraulic circuit, you don't have to supply electrons to an electric circuit. If you purchase a pipe at a hardware store, you have to supply the water. If you purchase an electron pipe, a wire, the electrons are already in the wire. Electrons are part of the atoms that make up the wires or any electrical devices in any circuit. They're not all bunched up in the battery, just ready to go, as some people think. Current direction? Since like charges repel, negative electrons are being repelled from the negative terminal of the battery into the circuit, moving in a direction toward the positive terminal to which they're attracted. But by convention, we say the direction of current is from positive to negative, the direction in which positive charges would flow. That's from the positive battery terminal through the circuit and toward the negative terminal. Flowing electrons get their energy from chemical reactions in a battery, deliver that energy to parts of the circuit, then return to the battery pooped out and ready for re-energizing. Actually, in most circuits, the direction of current isn't important. In some substances, like metals, electrons are loose enough to flow easily. These substances are electric conductors. In other substances, like rubber or plastic, the atoms hold their electrons tightly. These substances are electric insulators. How fast do electrons move in a typical electric circuit? Most people will say quite fast, maybe almost as fast as the speed of light. Not so. Surprisingly, the actual average speed of electrons moving along a typical circuit is very slow, like a snail's pace. We refer to this as drift speed. The actual speed of electrons bouncing hither and thither is in fact much greater, but only a tiny component of an electron's velocity is directed along the circuit on the average. What is really fast is the electric field, which moves at the speed of light. As soon as you close a switch in an electric circuit, the battery sends an electric field instantaneously through all parts of the circuit. So the electric signal travels at the speed of light. This is like marches in a parade. As soon as each person hears the signal "forward march," all step together. So it is with electrons in a circuit. The signal to move travels enormously faster than the motion of any individual. Is this information yum? I hope so. Another topic. We hear people say that current is used up in an electric circuit. Is this true? No, it's not true. The quantity that is used up in a circuit is not current, but energy. If current diminishes, it's likely because the energy supplied by chemical action in the battery, the voltage, decreases. The electric energy dissipates to become thermal energy. Let me leave you with a question. When electrons flow in a thin lamp filament, they experience friction. What is the practical outcome of this? Until next time, good energy.